My guys, I'm going to remind you about the fact that please be very quiet. No worries. Okay, now. Okay, now today's lesson is going to be a little bit, I should say, not a little bit. Of course, this is very interesting, but this is a little bit short compared to the other things that we have done because that's a very small topic. Then the rest is going to be you practice today. Now, we are going to talk about something. Huh? Oh, really? Now it's good? Yeah. Now, the thing that we are going to discuss today is going to be again the same thing. We are going to go again to the concept of the exponentials. However, so far, what we have been talking about, it was about the exponential functions. We said what? The exponential functions come within this form. We said that y, which represents the function, comes with the coefficient times a base, which is a positive real number, and it is raised to, let's say, for example, an f of x. And for simplicity, we saw that sometimes we are getting a little bit lazy, and we say that the function is going to be a times the base, a small, with the exponent as the x. F of x is found to be something easy. That's what we have been doing so far. All the exponents of the bases that they were positive real number, Lisa, they were just, for example, x. Now, these are exponential functions, but today we are not going to talk about exponential functions anymore. Still, we are going to work with the exponentials, but we are going to work with the concept. This is exponentials. Yes.
Fraction.
A little bit close, but equations. And that's the thing. So far, whatever we learned about the exponential functions, how do they behave? What is their asymptotic behavior, intercepts, increasing, decreasing, transformation? We all put them aside. Now we are going to talk about the case when those exponents appears as a function. Now, so as an equation, sorry, I got distracted by the board. Now, what do we mean by this? We have two methods, two strategies to solve an exponential equations. One of them, you are going to learn it at level 4. The other one, you are going to learn it here at level 3. But I'm just going to highlight the level, the second strategy that you can see what that's going to be. Now, the first thing, strategy, I call that strategy number 1. Strategy A. Strategy A is this. Now, you're going to learn it at level 3, then you are not going to see anything which goes beyond this method. Strategy A is this. You have, for example, some bases. I get, for example, one base. I'm going to represent it by this geometric figure. It means that you can fill anything in there. Then you have another base. I show it in a different, I should say, configurations. It means that they are going to be bases, but they look different. Now, and also they come with, let's say, for example, 2 different exponents. One of the exponents, we say that it's going to be f of x. The other exponent for the other base, it comes as g of x. We say that this is going to be a very generic form of an exponential equation. Why it's an equation? Because we see that there is an equal sign here. You see that? Something on the left equals something on the right, and that's the reason it's not function anymore. It's an equation. Now, however, you see that for the bases that we have this base here, and we have this base here. It means that they are different. For example, you have 2, one of the base, the other one is 3. Now, strategy number 1, what does it tell you? It tells you when you have this expression, you look at yourself as a carpenter. For example, you have a box, wooden block. You have, for example, some tools. You are just going to shape them. You have to shape them in a way that the bases now becomes the same. For example, I'm going to explain numerically. I'm doing this storytelling to familiarize you with the whole strategy. Then we just make the shapes to be equal. For example, now the base is, after we do work as a carpenter on it, it turns to be a kind of a circle. It equals to the right side. Now, it is the circle. It has the same expression. And we may think that also f of x and g of x may still remains the same. Then you see that this is strategy that we have. For the strategy number 1, strategy A, it focuses that you use some skills, you use some, I should say, tricks, that when you see exponential function equations, you do whatever you can to make sure that their bases are the same. For example, one of them was a square, for example, a square, the other one is a triangle. You work as a carpenter, now all of them, they are like this, like the circle. It means that the bases are the same. When that thing happens, when the basis becomes the same, then you come say, okay, now I know how to solve this equation. And the only way to solve this equation is this. We say now that as long as the bases are the same, I say that the exponents, they should be the same. Then as a result, f of x should equals to g of x. You see, that's the strategy. That's how we are going to solve exponential equation. And that's the reason I use geometric shapes to tell you that's going to be our roadmap. Any questions so far? No, now we go to some numerical examples. Let me use this color as an example on how to solve it. We just start from very simple, basic examples. As we move along, they are becoming, I should say, more interesting. Example number 1. I'm going to tell you solve this equation. For example, we have 2, it's as a base, which is raised to a power exponent, which is x, and all of it that exponential functions, because the base is something positive real number, it's not equal to 1. And as an exponent, it is raised to x. This is all the definition of an exponential function. Now we say that, now, if I equate it to something like 16, now this is not anymore an exponential function. Now this is an exponential equation, because now a function equals something. Now that's an equation, not anymore a function. That's very important to have a distinct understanding what is the difference. Now, what is going to be our task? Of course, look at this part, the part which I'm going to explain, it's very important. If you have something like that, you say y equals 2 raised to the power x. This is what? Exponential function. What is it? Sorry, what? No, this is a function. That's right. What is significant about this is that anything for the x is welcome. We say that x can be anything as a real number. It can be even 0, because 2 to the power 0 becomes 1. Then we say that everything as a real number is welcome for the x. Then the domain is a real number. However, look at the one which we have on the left. We take this one, 2 equals to the power x, equated to 16. And now look as it becomes an equation. Now, can I say again, x can be any real number. Everything is welcome for the x. Now, that's great. And that's the thing which makes exponential equations different from exponential functions. You do not have that much freedom to choose anything for the x. It's a very limited options that we have for the x. Now, then as a result, for the x that we have here, Not everything is welcome. Only one item, maybe one number can be relevant. Now, then as a result, when we say solve an exponential equations like the one which we have here, it means that find the value, exclusive value for the x that makes this equation valid. Now, how to find it? Now we just say how to find it. Okay. Now we just go back to the previous system. The previous slide said that if you have an exponential equation, the bases are different. One is a square, Celia. The other one is triangle. We do whatever that we can to be smart, to just change them to have the same basis. Both of them now they are sacred. Then as a result, we say that the exponents now can be the same. Then as a result, what is the pronunciation? Then as a result, I'm just going to look at this expression and try to make any changes that 2 equals to x equals to 16, that the bases look the same. Now our strategy starts. I'm going to look with this one. I say 2 to the power x. I'm going to keep 2. And the x, which I'm just going to find it, I keep it there. But I say, okay, on the right side, what is the exponent of 16? 1. But the thing is that these two exponents are the same, and they are not going to be valid based on the thing that you learn. The bases, one of them is a square, the other one is triangle. You have to make them to look the same. How to do that? You say, wait a minute. I have to be a little bit skillful, say that, okay, I'm just going to rewrite the thing which I have on the right side, that it also has the same as the base as 2. Because in that case, you see that the left base is equals to the right base, and that's what we want. But you know that 16 is what? That's right, 2 times 2 times 2 times 2, as Lucas said, 2 to the power 4 becomes 16. Then as a result, I notice that here, instead of 16, I can write 2 to the power 4. If that's the case, look at this. Previous slide, now we have from both sides as a circle. The basis remains the same. Then what do we say? We say that, okay, as long as the bases are the same now, we say that now the exponent also should be equal. And that was our strategy. Then as a result, we say that as a conclusion, x, it has to be necessarily only and only to become 4. And the solution is that you see that 2 to the power of the x as a function had every real number welcome for the x, but for this equation, only and only number 4 is valid. You see, that's the distinction between a function and equation. Everyone is happy? Yeah. No questions? No. Fantastic. Now, I do the second problem. Solve the second problem, then I give you some problems you just work in your groups to solve it. Now, we just move on to the next example. The next example is this. We say that 3, if we choose it as a base, which is raised to the power x plus 2, it's now equals to 1 over 27. Now, we just want to solve this. Now, we know we have only one strategy to solve this equation. We know that we have to make the bases to be exactly the same. Now, we are just going to do some manipulations to make the base looks like the same. Now, the first one here, we have 3. But what is the other base on the right side? 27. Now, the other base is 1 over 27. Oh, yeah. You see, it's 1 over 27, which is raised to power 1. Now, they are widely different. 2 different bases. Now, our work starts here. How to make 1 over 27 to become to 3. That's our task. The task is that we have 3. We are going to use a band to transform it. to 1 over 27. And the question is how? If we do that, the problem is solved because the exponents are going to be the same. Now, look at this. 27. 27 is what? Can I write it as 3 times 3 times 3? 3 times 3 becomes 9. 9 times 3 becomes 27, right? Then as a result, 27 can be written as 3 raised to the power 3. You see? Then now it seems that, okay, we can have that's quite a relief. Now I know 27 is like 3 to the power 3. Now, I can rewrite this. I had 3, which is raised to the power x plus 2, now equals to what? Equals, still I have 1 on the numerator. But I had 27, which it was on the denominator as 3 to the power 3. You see, so far good, everyone? Yes. Now, and Matthew, look at this. I said, Matthew, I said, Daniel, look at this. Still, sorry, I just pointed people. I just want to make, I guess, there's nothing wrong. It means that, now look at this. There is still a problem here. The base which I have on the left side, this is 3. The base which I have on the right side, it shows 3 in there, but this is at the basement. It is not exactly the same like the base on the right side. Now, you ask yourself, can you do anything to... The problem that we have to ask ourselves here is that, can we do anything that we can bring whatever is downstairs, bring it upstairs, then this problem is going to be resolved? Can we do that? How? That's fantastic. That's right. We learned that identity before. I'm going to rewrite it here as a kind of a review. We said that if we have a base, it comes with an exponent which is negative. It can become positive as long as it goes to the basement, I mean to the denominator, provided you change the sign to positive. Or vice versa. You have something at the basement, you want to change it to the roof, then you only change the sign and becomes minus to plus or plus to minus. Yes, Sima? Then as a result, what I have here, I can write it like that. I say 3, which is raised to the power x plus 2, can be written like that. 3 to the power 3, it's coming to the roof. It becomes 3 to the power of what? Minus 3. That's right. Now, guys, look at this. That's what we wanted. We see that here, both of the bases, now the same. They have 1 3 here, 1 3 here. Like both sides are like these square circles that we were talking. Now, we say that. That's a huge conclusion now. As long as the bases are the same, we say that the exponents can be the same. It means that as a result, x plus 2 should equals to what? That's right, because now these ones are going to be the same. Now, from here, you say, are you kidding me? It's a very easy task to do that. Because x becomes, you take 2 to the other side, becomes minus 5. And that's the thing that we wanted to solve. And essentially, this one wraps up the strategy that we are going to use all the time then when we have an exponential equations. Then make the bases the same, then take the exponents the same, becomes equal. However, when you go to level 4, you see that there are cases that it is impossible to make the bases becomes equal. Then there is a new concept you learn next year. It's called logarithmic functions and logarithmic operation. It's going to be for next year. But this year, whatever we have, we can do some manipulations to make the bases look each other. Any questions? No. Then now, I'm just going to give you example that you take your time to follow these steps to solve. Everyone is ready? Fantastic. Remember, if you want to work with a friend, please be very quiet. Okay? Now, I give 3 examples to solve. I'll give 3 examples. Let's start by this. The first one is 3 raised to the power x plus 1 equals to 1 over 27. The second one is going to be 5 to the power 1 minus 2x equals to 1 over 5. And the third one, as an example that we're going to have, is going to be this. It's going to be, let me pick up something which is 4 to the power 2x plus 1 equals to 8 to the power 1 minus x. And the last one, it is going to be this 4 times 1 over 3 to the power x should equal to 36. Now, these 4 ones, let's work on them. Let me just temporarily, I pause the recording. I'm going to read. Okay, now, I'm going to solve all of them. First, we are just going to try this one, the first one. 3 to the power what? X plus 1 equals to 1 over 27. It's very similar exactly to the thing exactly which I solved that for you on the board, just only one minor problem. You notice that, first of all, you have to make sure that the bases are the same. Then as a result, in order to rewrite it, we write 3 as a base, which is written, and the exponent remains the same as x plus 1. But we learned that we can write 27 as 3 to the power 3. Now, the task that we have in front of ourselves is that to take this one, bring it all the way up, which it gets a negative exponent, which it means it becomes like that, becomes 3 raised to the power x plus 1 equals to 3 to the power minus 3. Then now you see, look at this. I built something which from both sides, the bases are the same. Then let's take, I should say, the exponents equal to each other. You mean that then this expression should equal to this, which means what? Then x plus 1 should equal to minus 3. Then as a result, we take plus 1 to the other side of the equality. We change the sign. X becomes equals to minus 4. That's the answer for the first one, which was so similar to the one which I solved that for you when I was giving the lecture. The second one is what? 5 to power 1 minus 2x. 1 minus 2x equals to what? 1 over 5. Am I correct?
Yeah.
Awesome. Guys, look at this one. We take a look. We see, oh, look at this. Again, what we are dealing with is that exponential equations, because the x that we're going to find shows up there as an exponent. Then the first step is that to identify what are you dealing with, and that's an exponential function. As a strategy, we know that we have to do some manipulations from both sides, that both sides, I should say, the basis becomes equal. Then I say, look at this. This one, which I have 1 over 5, if I bring it all the way to the roof, it turns out to take that form, then becomes 5 to the power minus 2x equals to 5, but with the exponent as minus 1. Because 1 over 5 has an exponent which is 1. That's obvious. Yes, Matthew? Then as a result, we say that, take a look here. The bases are the same. That's a good sign. That's a good sign because it means that then you can take the exponents to be equal to each other. Then as a result, you say 1 minus 2x should equal to minus 1. From here, it's going to be an easy task. You say, okay, I'm just going to take minus 2x to the right side, take minus 1 to the other side. Then I get 2 equals to 2x. You divide both sides by 2, you get x equal to plus 1. Yes? Yeah. Makes sense, everyone? Yes. Yeah. Everyone happy? No questions? Awesome. Now, what was the third one? 4 to the power 2x plus 1. 4 to the power 2x plus 1. Awesome. Thanks, Elisa. Now, look at this one. This one is very interesting. But before we explain this, I'm just going to remind you, Matthew and Rocco, of a very important identity. You learned it before. What was that identity? The identity was this. We said that if we have a base, which is raised to an exponent, which is, for example, m, and all of it is raised to the another exponent, which is n. What happens there? We say that, okay, we are just going to write one base. However, the exponents n and m is going to crush into each other, be multiplied into each other, Lucas, and instead we write what? We write m times n as an exponent. That is sometimes very useful identity, Lucas. Now, I'm just going to have this in mind and go ahead to solve this problem. Now, look at this. This one is a little bit, I should say, a trickier one. Why? Because we have 4 and we have 8 at one base. So far, what we used to do was that we normally got the base from one side, Elisa, and we tried to make the base on the other side to look like that. Now, both of them are different. Now we have to work on both sides to just craft them and modify them to make them look exactly like each other. And as a kind of, I should say, strategy that we are just going to adopt, we know that 4 can be written as 2 times 2, which means that we can write 4 as equals 2 to the power 2. Am I right? Yeah. No argue. How about 8? We can write 8, 2 times 2 times 2, which means that 8 can be written as 2 times to the power 3. Yes? Yeah. Then we see that, look at this. We have 8 and 4 can be written in exponential formats that they share the same base. And that's what we want. We want to reconfigure them that all of them have the same base. Now, then as a result, in order to solve this one, I'm going to write it here like that. Instead of 4, I'm going to write what? 2 to the power 2. However, I'm not going to forget about this exponent, which means that 2 to the power 2 is raised also to the exponent as 2x plus 1. That's very important. Equals to, instead of 8, Ella, what should I write? That's right. I write instead of 8, 2 to the power 3. But at the same time, I'm going to be careful that 2 to the power 3 is raised to the power 1 minus x, because 1 minus x is the actual exponent of the 8. Now, from here, you see that we have the crushing roots. Why? Because we have the exponent 2, we have 2x plus 1. That's this identity that we discussed. It means that they have to be multiplied with each other. The same thing is valid for this. This one also, they have to crush into each other to be multiplied. Then as a result, from here, what do I get? I get 2, and I multiply 2 into 2x plus 1. And on the other side, I have 2, which I multiply 3 to 1 minus x. Then now, look at this one. I have an exponential equation, which now I have the basis for both sides the same. Quite a relief. Why? Because I can say that now the exponent which I have for them, which is one this one and the other this one, they should be equal. Means what? Means here that I'm just going to expand 2 to the other one. Now, let me just write it here not to get it confused. Equals to 3 times 1 minus x. Now, let's expand 2 to the other side. What do I mean? I'm going to take 2, expand this once to this, once to the other one, and 3 once to this and once to the other one. I'm going to rewrite it. Then I get 4x plus 2 equals 3 minus 3x. To solve this, I say I take 3x to the other side. Then I get 4x, and I get 2 to the other side. Becomes 3 minus 2 becomes what? 1. Then how much is value of the x now? Oh, sorry, 7x. Awesome. Thank you. Thanks for correcting me. It becomes 7x equals to 1. Then as a result, x equals to what? That's right, 1 over 7. And that's the answer for this equation. Any questions? But guys, you know that these lectures are recorded. And this slide also is going to be posted on the Google Classroom. Yes? Yes. Awesome. Now, we are going to the last one, I think, huh? 4 times. Yes. Yes, please. 1 over 3 raised to the power x equals to what? 36. And now that's going to be that one. Okay, now let's solve this one. This one is a little bit, I should say, peculiar in a sense that before we just make the bases look each other, we have to do some minor, I should say, adjustments. And what is that adjustment that we are going to make? Is this, that we say that, okay, I'm going to remind you of this. We said that if we have a coefficient, for example, is multiplied to x and it becomes equal to b, then the best approach to solve is that divide both sides by the coefficients of the x, which is a. Then we write x equals to b divided a. That's very obvious. I'm going to do the same thing here. Look at this. We have 4 here, which plays the role as the coefficients of the x. Then it means that before we try to make the coefficients look like each other, it's better to divide both sides by 4 to get rid of that coefficient. Then what we are going to be left with is 2 pure bases, the bases that they are not being annoyed by 4. Look at this, because I believe that 4, which is standing before this base, is annoying 1 over 3. That's so much annoying thing to have it there. Then let's get rid of this. Then divide both sides by 4 to get rid of this annoying factor. It means that then I divide both sides by 4. Then the left side becomes 1 over 3 raised to the power x becomes what? Equals to divided by 4. 36 divided by 4 becomes how much? 9. Fantastic. Now, Look at this. I can rewrite this like that. I say, oh, look at this. For one base, I have 1/3. The other base is 9. However, guys, we know that very easily that 9 can be written as 3 to the power 2. Am I right? Yes. Then let's do this. There becomes 1/3 raised to the power x becomes 3 raised to the power 2. Still there's a problem. One side, the base is 1/3. The other side is base is 3. It reminds you of this identity again. That you have a base with the negative exponent, you can bring it to the basement, the positive exponent. Lucas, then what's going to happen then now?
3 to the power of 1.
Then,
Never mind.
no, because I want to bring 3 up there, because I just want to make the basis. I want to take it a little up there. That's right. Then as a result, what do I get? I get 3 to the power -1, which is, don't forget the x, which is raised to the power x, should equal 3 to the power 2. Now, look at this. I have one exponent here, Matthew, one exponent there. They want to fight. They are just going to crash into each other and they get multiplied into each other. Then what do we get? We get 3 to the power -x equals to 3 to the power 2. Quite a relief. The bases are not the same. The exponents that they can be equal to each other, which as a result, it means that, let me write it here, -x should be equal to 2. Then you can conclude that x itself is -2. And that's the solution. Any questions? Everyone happy? Awesome. For the people who are at home, guys, any questions?
No, I'm good.
No? Awesome. Now, guys, we have almost 15 minutes. I'm gonna give the homework which you have to do right now. You have two choices. You can either spend some time in the class with your partner to solve it, or you can just say, okay, I'm gonna relax, take a deep breath, but I don't recommend it. Then you have only one option. And the option is that you're doing your homework right now. Okay, I give you two equations to solve. Do whatever you can today, and the rest will be done. That's right. 4 raised to the power x (1/4) power of 1 minus x equals to 32. The other one is 25 1 minus x over 125, and the third one is going to be this 5 times. That's right, but it's recommended you do it now. Right now. Okay, now this is the thing. Daddy, please do this now. I'm just gonna temporarily stop the share to pause the recording.